Velvet worms are a diverse group of invertebrates with a lineage dating back over 300 million years. These guys are best known for their glue blasting capabilities, and these critters are as interesting as it comes. And today, we'll be talking about the largest member of the velvet worms, Manghiperipattis solorzanoi, more commonly known as Solorzano's velvet worm. Now before we dive into this specific critter, let's get a little more info on velvet worms. Velvet worms belong to the phylum Onychophora. Onychophorans are these worm-like, soft-bodied, segmented invertebrates that are named specifically for their velvety texture. You see, this texture actually comes from the scaly papillae found on their skin. Now, there are over 200 species of velvet worms, and these 200 species are divided into two extant families, those being Peripatopsidae and the family that today's critter belongs to, Peripatidae. This division is usually done based off of a few factors, the first being geographical distribution. Peripatidae are equatorial and tropical, found in places such as South America, Central America, the Caribbean, parts of Africa such as Gabon, Northeast India, and Southeast Asia. Peripatopsidae are all the species that are found south of the equator, in parts of what was once the ancient supercontinent Gondwana. Species from this family can be found in Chile, Australia, Southern Africa, New Guinea, and New Zealand. The second of these distinctions are morphology and leg count. You see, Peripatidae are known to have more leg pairs, usually possessing 19 or more pairs, with some species reaching up to 43 pairs of legs. Meanwhile, Peripatopsidae tend to have fewer leg pairs, with most species having 15 or fewer. And the third is reproductive strategy. C. Peripatidae are viviparous, which means they give birth to live young. Now, what's special about their viviparity is that they actually possess placental structures. We'll be diving into that later in the video. Meanwhile, Peripatopsidae display diverse modes of reproduction, which include oviparity, which is egg laying, ovoviviparity, which is retaining the eggs inside of the critter, and viviparity, but this time without a placenta. There is so much more to talk about when it comes to velvet worms. These are such cool critters, and as for the rest of the information about velvet worms, that will be explored later in another episode. There is a lot more to explore about the Solorzano's velvet worm, and we'll dive more into that in later concept videos. We'll call them Annie concepts. Now, you know that red velvet worm we've been showing you throughout the episode so far, talking about this one right here? Yeah, so that is the Solorzano's velvet worm. So let's talk about what a Solorzano's velvet worm actually looks like in the wild. The Solorzano's velvet worm measures at a striking 22 centimeters in length. Their bodies can range in color from light brown to wine red, and their legs are this contrasting pale yellow. They do express sexual dimorphism in a very intriguing way at that. Their leg count. The very original description of this species reported that male specimens only possessed 34 pairs of legs, while the females ranged from 39 to 41 leg pairs. Matter of fact, out of the 14 females observed, 11 of them possessed 41 leg pairs. This creature is so intriguing, and one of the most interesting things about them is the fact that they share so many features with their close relatives Manghiperipattis ciccoldi that one of the only ways that scientists can tell the difference between them is by the spinous pads on the soles of their feet. See, Manghiperipattis solorzanoi have 4 spinous pads on the soles of their feet. Meanwhile, Manghiperipattis ciccoldi have a 5th vestigial spinous pad on the sole of their feet. Now, throughout this video, we have been very vague about what is known about the Solorzano's velvet worm, and the reason being is the fact that the Solorzano's velvet worm is a newly described species. Now, speaking of discovery, let's talk about who, what, when, and where this species was discovered. And before we dive into that, I need you guys to jot down 2 definitions that will be very helpful in this next segment. Holotype. A holotype is the original specimen that is used for the description of a species. And paratype. Think of them like the supporting cast members that help give the species its scientific name and further its description. With that out of the way, let's dive in. The Solorzano's velvet worm was actually described in 2010 by biologist Bernal Morera Perenes and Julian Monge Najera. This description was based on 14 female specimens and 2 male specimens. These specimens included the female holotype found by the Costa Rican herpetologist Alejandro Solorzano in Guayacana de Esquerres in Costa Rica in 1996, 4 young paratypes born to the holotype soon after her capture, and a few other paratypes collected in 2000. Biologist Bernal Morera Berenes and Julian Monge Najera named this species in honor of Alejandro Solorzano, who originally discovered this species. The original holotypes for this species are deposited in the Museo de Zoología de la Universidad de Costa Rica in San Jose, Costa Rica. Costa Rica is such a beautiful and biodiverse country. It's actually home to some of the prettiest and most beautiful poison dart frogs. Now, where specifically within Costa Rica does the Solorzano's velvet worm live? Well, based on what is known about this critter, it appears that it's not only extremely elusive, but it's also very limited to a very small area within the Limón province in Costa Rica. They've been observed in Brabella National Park, Pacuere River Forest Reserve, and the Guayacan Rainforest Reserve. Now, like other velvet worms, the Solorzano's velvet worm has the remarkable ability to fit in between narrow nooks and crannies, right? So you can find these guys underneath leaf litter, in between rocks, on top of rocks. They are elusive though, so they're not easily found. Now, we've been withholding on the superpower segment for long enough, all right? So let's address the glue in the room and what that glue actually does. Like all other velvet worms, the Solorzano's velvet worm is capable of spitting quick hardening slime that comes from an oral papillae near its mouth. The slime is actually made from highly unstructured proteins and a few other trace compounds. That's what we've been calling the glue. Reason being is it acts as such. Velvet worms are incredibly predatory, feeding upon other invertebrates such as crickets, spiders, woodlice, etc. So when they spot a prey item, they'll spray the slime, which glues the prey in place, allowing the velvet worm to trot its way over to its food before using its jaws to inject digestive enzymes into the poor critter and then suck out the liquefied insides. They also expel a concerning amount of slime when they feel threatened, and this is in order to trap their predator and make a quick escape. Now, there isn't any actual documentation about what predates on the Solorzano's velvet worm, but one can assume that smaller mammals and reptiles near the forest floor, as well as amphibians living near the streams that they live by, might be able to make a meal out of this critter. Unfortunately, we're nearing the end of the video. And like always, I always save the reproductive habits and behaviors towards the end of the video. So let's talk about the Solorzano's velvet worm's reproduction. Little is truly known on when or how this species actually reproduces. This is due to velvet worms being incredibly diverse and this specific species not getting all that much attention. What can be inferred, however, is that like other peripated species of velvet worms, the Solorzano's velvet worm do not lay eggs and instead carry their young in a uterus-like organ where these embryos are nourished by a placenta-like structure. It's theorized that like other peripatids, the gestation period for the Solorzano's velvet worm's young can take up to 15 months. What is super intriguing is that the embryos within the mother can develop at different stages. This means that a single female can carry multiple young, all in varying ages, kind of like a sausage link of babies. When the young are born, they are fully functional and independent of the mother. And that about wraps it up today, folks. I hope you enjoyed this video, and don't forget to